Hi guys, it's a favorite teacher, Kaumajimaza, and welcome to Learning Science the Easy Way. So for those that are watching me for the first time, on this platform, I teach sciences, physics, and chemistry. So I encourage you to subscribe to my YouTube channel so that you'll be able to receive a notification whenever a new video is posted. So in this lesson, I'm going to talk about ionic bonding and the formation of ionic bonds, as well as the characteristics of ionic compounds. In the previous video, I talked about ion formation, where how ions are formed either by gaining of electrons or losing of electrons. So in the same line, we are going to look at ionic bonding. So we are saying ionic bonding is the transfer of electrons from a metallic atom to a non-metallic atom. So the transfer of electrons also here, it also involves the losing of electrons as well as the gaining of electrons. So in this context, we are saying the metallic atoms, they are the ones that loses the electrons. Then the non-metallic atoms gains the electrons. So when a metallic atom loses the electrons, it becomes positively charged. And that is what we are calling as the cation. And when a non-metallic atom gains the electrons, it becomes negatively charged, and that is what we are calling as the anion. Let us look at the formation of sodium chloride as one of the ionic compounds. So sodium chloride consists of sodium atom and also chlorine atom. So sodium with the electron configuration of 2, 8, 1, then chlorine with 2, 8, 7. So this simply shows that sodium has got 1 electron in the outermost shell, then chlorine has got 7 electrons in the outermost shell. So for sodium to be stable, it is supposed to give out or to lose the electron in the outermost shell, which is 1 electron in the outermost shell. Then for chlorine to be stable, it is supposed to gain 1 electron in the outermost shell. Now, so what we just have here is the atomic structure for sodium and also the atomic structure for chlorine. So sodium will lose 1 electron, which is in its outermost shell. Then chlorine will also gain 1 electron in the outermost shell. So when sodium loses this electron to chlorine, so say lost there, so it loses the electron to chlorine. So what we are going to have at the end of the day, so what we are going to have is sodium ion with 2 shells, since the outer shell has been lost as well. Then since it lost 1 electron, you put a positive there since it has become positively charged. So this is sodium ion. Then you write for the chloride ion. Okay, like that. Then you indicate the electrons. Indicate the electron nicely. with the electron that has been gained, then it becomes negatively charged. So this one is the chloride ion. So this structure which we have is what we are calling as sodium chloride as an ionic compound. Okay, so we can also look at the formation of magnesium oxide. So magnesium with the electron configuration of 2, 8, 2. Then we have the oxide or oxygen, which has got 2, 6. So magnesium has got 2 electrons in the outermost shell, and oxygen has got 6 electrons in the outermost shell. So in this case, magnesium will lose the 2 electrons to oxygen. So we have the magnesium atom and as well as the oxygen atomic structure. So magnesium will lose the 2 electrons to chlorine. So 2 lost electrons to chlorine. And what we are going to have is the magnesium ion. You have the magnesium ion like that. Always you remember to indicate the charge of the magnesium ion. So we have magnesium ion like that. Then you write for the oxide ion. The oxide ion and the 2 electrons gained. So you indicate as well as like that, then the oxide ion like that. So what we have here is what we are calling as magnesium oxide. So this is magnesium oxide, which is formed by the combination of magnesium and oxygen. So basically, when these two combine, there is the loss and gain of electrons in order to form magnesium oxide. We can try to look at the physical properties of the ionic compounds. So one of them is that they have a high melting and boiling point. They have a high melting and boiling point due to strong bonds in their structure. So this is the reason why they have a high melting and boiling point, because for you to overcome the bonds or to break down the bonds, you need a lot of energy. More energy is needed to break down the ionic bond, and this is the reason why they have a high melting point and a high boiling point. Okay, so we can also say most ionic compounds are soluble in water. So water is a polar solvent. Water is a polar solvent because its molecules are polar, and those polar molecules are the ones that are attracted to the charged ions in the ionic compound, hence making the compound to be able to dissolve in water. Okay, you can also say the ionic compounds cannot conduct electricity. In solid state. unless in molten or aqueous state. So ionic compounds do not conduct electricity when they are in solid state, unless when they're in molten state or in aqueous state. So this is because the ions in the ionic compound, which is in molten state or in aqueous state, they become mobile. And the mobile ions are the ones that carries the charge. That's why we are saying the ionic compounds are able to conduct electricity when they are in molten state or in aqueous state. I hope you followed through, and thank you very much for watching.